Class 11th, I am telling you about the angle of friction and angle of repose. Let this now is surface. Here a body. Now this is now reactional force R. This is now weight W equal to mg. Now this is now suppose the angle. This is here this the friction, force of friction, and then we complete to this like this, and this will be the resultant force F, and this is the angle of this angle theta. This angle is theta. So now let's, here this is now applied force. Applied force. Let Fr equal to friction force R equal to normal reaction then you can have that this is suppose I take this is now point here, this I take now point A, this is now point B, this is now point C. So resultant of Fr and R. This you can see from here that this line AC, this F equal to square root of what? That we are having this Fr square plus R square, and we know that this Fr is equal to mu R. Mu the coefficient of friction. So this is equal to square root of mu R whole square plus R square. This is now your square root of mu square R square plus R square. So now you can have this R square root of mu square plus 1. This is now for resultant friction. This shows the resultant force of the force of friction and the normal reaction. Let this resultant force makes an angle theta, or this is represented by lambda. Let lambda equal to angle between F and R, the resultant force and the normal reaction. So we can have from right angle triangle. This is now your ABC. This 10 lambda is equal to your BC perpendicular upon, this is now perpendicular upon base AB. So this BC is what? BC This is now your FR. AB, this is now this. This is now what? The normal direction R. So what we have? This FR equal to mu R, as we know this, mu, where mu equal to coefficient of friction upon R. This is equal to what? 10 lambda. R and R will cancel. So 10 lambda is equal to mu. Now this lambda is called the angle of friction. Lambda is called angle of friction. So what to define this angle of friction? The angle between the resultant of the frictional force and resultant force, and that is with this reactional force, then that is called the angle of friction, lambda. Angle of friction is defined as the angle between resultant of FR that resultant F makes with normal reaction. So what we have? Angle between the resultant F and normal reaction. F and normal reaction. Normal reaction R. This we will say R. So now you can see. Now we have to find that what should be the maximum and the minimum value of the angle of friction. Now this question was asked in the NEET exam. When it was given that you are given the coefficient of friction, you are given the result that normal reaction, then you find the expression for what is the expression for the resultant force of the frictional force and the reactional force. So this was given the option F equal to R square root of mu square plus 1. In place of write R, you can write down this weight mg. So here the mg can also be written here. So do not forget that this R is equal to mg. R equal to mg. So we can write mg here also. Then this will be F equal to mg into square root of mu square plus 1. So now what we have? Suppose maximum and minimum value of for perfectly smooth surface, mu is equal to 1. Mu is equal to 1. Then 10 lambda is equal to 1 or lambda equal to 45 degree or pi by 4 radian. This is the maximum value. Because for perfectly smooth surface, the coefficient of friction is equal to 1. No. Mu is equal to 0. Mu is equal to 0. This is not 0. Since there is no friction at all means this mu coefficient of friction mu is equal to 0. So this is the minimum value. And for perfectly rough surface, mu is equal to 1. So 10 delta is equal to 1 or lambda equal to 45 degree or this is now pi by 4 radian. So maximum value of lambda is how much? 45 degree and minimum value is how much? 0 degree. So lambda maximum is lambda maximum. This is equal to 45 degree or pi by 4 radian and lambda minimum this is equal to 0 degree. So what happens? That this lambda generally lies between 0 and 45 degree. So what we have? Generally. Now this lambda is less than pi by 4 and greater than 0. So for all surfaces, this value of lambda will lie between 45 degree and the 0 degree. This is what the angle of friction that I have told you. Now we take the angle of repose. Angle of repose. Now that we are having this inclined plane, this is now suppose A, B, this is now your suppose C. This is now H. And let this is the angle theta. A body is placed here. This is now your body. Now this is now reaction force and it will have the weight vertically downward. This is now mg. So now this angle will also be angle theta. So this we have this mg cos theta, and towards this one we are having this mg sin theta. mg sin theta. So what we have? A, B, and this is now equal to C. Let theta equal to AC is inclined plane on which having a body of mass m over it. Now this inclined plane is raised slowly. The inclined plane the inclined plane AC is raised making an angle with the horizontal. When this is raised slowly, then at a certain angle, the body placed on it start to slide down. For a particular angle of inclination, the body starts to slide down. This angle is called the angle of repose. This angle is called the angle of repose. So let theta is the angle of repose. Let theta equal to angle of repose. The body starts to slide down. It means that the force of friction will act vertically up towards this point C. So the force of friction will be like this. This is now force of friction. The force, the frictional force. Frictional force Fr will act towards opposite to the slide of body. That is, this will be directed towards like this one. So when the body just starts to slide, it means that if this angle is slightly raised beyond this angle theta, the body will come down. For equilibrium, what we will have, that this Fr is equal to mg sin theta and this R is equal to mg cos theta. So now if we divide Fr upon R, this is mg sin theta upon mg cos theta, this m will cancel. So what we have, this Fr, the frictional force, Fr equal to mu r, mu the coefficient of friction. Coefficient of friction. So what we have, that this mu r upon r, this is equal to tan theta. So this r and r will cancel. Again we are having. So mu e tan theta is equal to mu. It means what? Then the tangent of the angle of repose is equal to the coefficient of friction. Thus, tangent of angle of repose is equal to coefficient of friction. Coefficient of friction. And you know that this coefficient of friction, again we are having the value to this, that mu is equal to 0 for perfectly smooth surface and this is equal to 1 for perfectly rough surface. So the angle of theta will come out to be 0 and 45 degree. It means that this, suppose this is the inclined plane here, this we are having this, and now this part is raised like this. And suppose this makes an angle of 45 degree, then body will be at rest. But if it is slightly more, then body will come down. So the body will slide when this angle is more than 45 degree. So you can have that this theta for perfectly smooth surface, mu is equal to 0. So tan theta equal to 0 or theta equal to 0 for perfectly rough surface. This mu is equal to 1. So theta equal to 45 degree. Theta equal to 45 degree or pi by 4. Ready. Now we can draw the relation between the angle of friction and angle of repose. Relation between angle of friction and angle of repose. So now we know the angle of friction we have this 10 lambda is equal to mu, and angle of repose we have this 10 theta equal to mu. Mu is same in both the cases, so 10 lambda is equal to 10 theta, or this lambda equal to theta. It means that the angle of repose is same as the angle of friction. Thus, angle of friction and angle of repose are equal to each other. Or we can have that this lambda upon theta, this is equal to 1, or lambda ratio theta, this is not 1 ratio 1. We can also write it, or we can also write it. So the ratio of the angle of friction and then the angle of repose is equal to 1 ratio 1. So this is what is very critical one, that generally not written in the box. So you find the ratio of this lambda and theta. So this is about the angle of friction and the angle of repose, and the relationship between them, the maximum and the minimum value. So from here you find that the maximum value is 45 degree and minimum value is 0 degree. So this is what the angle of friction and angle of repose. So thank you very much.